Examples: auction of a single item. The Vickery auction that we started our discussion with is a special case of a VCG mechanism with the Clark pivot rule. Here, A equals to the set I wins such that little I is in capital I. Each player has value 0 if he does not get the item, and may have any positive value if he does win the item. Thus, capital VI equals to the set of little vi such that vi of I wins is greater than or equals to 0, and for all j not equals to I, vi of j wins is equals to 0. Notice that finding the player with highest value is exactly equivalent to maximizing the summations of vi of I summing for all I, since only a single player gets non-zero value. VCG payments using the Clark pivot rule give exactly Vickery's second price auction. Reverse auction. In a reverse auction, procurement auction, the bidder wants to procure an item from the bidder with the lowest cost. In this case, the valuation spaces are given by capital VI equals to the set of little vi such that vi of I wins is less than or equals to 0, and for all j not equals to I, vi of j wins equals to 0. And indeed, procuring the item from the lowest cost bidder is equivalent to maximizing the social welfare. The natural VCG payment rule would be for the mechanism to pay to the lowest bidder an amount equal to the second lowest bid and pay nothing to the others. This may be viewed as capturing the spirit of the pivot rule, since the second lowest bid is what would happen without I. Bilateral trade. In the bilateral trade problem, the seller holds an item and values it at some 0 less than or equals to Vs less than or equals to 1, and a potential buyer values it at some 0 less than or equals to Vb less than or equals to 1. The constants 0 and 1 are arbitrary and may be replaced with any commonly known constant 0 less than or equals to Vl less than or equals to Vh. The possible outcomes are A equals to the set no trade, trade, and the socially efficiency implies that trade is chosen if Vb is greater than Vs, and no trade if Vs is greater than Vb. Using VCG payments and decreeing that no payments be made in case of no trade implies that in case of trade, the buyer pays Vs and the seller is paid Vb. Notice that since in this case Vb is greater than Vs, the mechanism subsidizes the trade, as we will see below in section 9.5.5. This is unavoidable. Multi-unit auctions. In a multi-unit auction, k identical units of some good are sold in an auction where k is less than n. In the simple case, each bidder is interested in only a single unit. In this case, A equals to the set of S wins such that S is a subset of I and the size of S is equals to K, and a bidder's valuation VI gets some fixed value V star if I gets an item, i.e. VI of S equals to V star if I is in S and VI of S equals to 0 otherwise. Maximizing social welfare means allocating the items to the k highest bidders, and in the VCG mechanism with the pivot rule, each of them should pay the k plus first highest offered price. Losers pay 0. In a more general case, bidders may be interested in more than a single unit and have a different value for each number of units obtained. The next level of sophistication comes when the items in the auction are heterogeneous, and evaluations can give a different value to each combination of items. This is called a combinatorial auction and is studied at length in Chapter 11. Public project. The government is considering undertaking a public project. e.g. building a bridge. The project has a commonly known cost C and is valued by each citizen I at a privately known value Vi. We usually think that Vi is greater than or equals to 0, but the case of allowing Vi less than 0, i.e. citizens who are hurt by the project, is also covered. Social efficiency means that the government will undertake this project if and only if the summations of Vi summing for all I is greater than C, the commonly known cost. This is not technically a subcase of our definition of maximizing the social welfare, since our definition did not assume any costs or values for the designer, but becomes so by adding an extra player government whose valuation space is the singleton valuation, giving cost C to undertaking the project and 0 otherwise. The VCG mechanism with the Clark pivot rule means that a player I with Vi greater than or equals to 0 will pay a non-zero amount only if he is pivotal. That is, the summations of Vj summing for all j not equals to I is less than or equals to C, but the summations of Vj summing for all j is greater than C, in which case he will pay Pi equals to C minus the summations of Vj summing for all those j not equals to I. A player with Vi less than 0 will make a non-zero payment only if the summations of Vj summing for all j not equals to I is greater than C, but the summations of Vj summing for all j is less than or equals to C, in which case he will pay Pi equals to the summations of Vj summing for all j not equals to I minus C. One may verify that the summations of Pi summing for all I is less than C unless the summations of Vi summing for all I is equals to C, and thus the payments collected do not cover the project's costs. As we will see in section 9.5.5, this is unavoidable. Buying a path in a network. Consider a communication network modeled as a directed graph G equals to VE, where each link, little e in capital E, is owned by a different player and has a cost C greater than or equals to 0 if his link is used for carrying some message. Suppose that we wish to procure a communication path between two specific vertices, ST in V, i.e. the set of alternatives is the set of all possible ST paths in G, and the player E has value 0 if the path chosen does not contain E, and the value minus C if the path chosen does contain E. Maximizing social welfare means finding the shortest path P in terms of the summations of CE summing for all E in P. A VCG mechanism that makes no payments to addresses that are not in P will pay to each E0 in P the quantity, the summations of CE summing for all E in P prime minus the summations of CE summing for all E in P minus the set E0, where P is the shortest ST path in G, and P prime is the shortest ST path in G that does not contain the edge E. For simplicity, assume that G is two-edge connected so that a P prime always exists. This corresponds to the spirit of the pivot rule, since without E, the mechanism can simply not use paths that contain E.